Ladies and gentlemen, this is Forms of Energy and correlates with Chapter 12.2 in your textbook. Your key concepts for this video are: what are 6 forms of energy? Identify each energy form as kinetic or potential energy, and how can you calculate the mechanical energy of an object? So, what are the 6 forms of energy? You know that energy can be divided into 2 types, potential and kinetic, but from there it can be further subdivided into 6 forms of energy. We've got mechanical energy, chemical energy, nuclear energy, electrical energy, electromagnetic energy, and thermal energy. Let's look at these each a little bit more in depth. So mechanical energy is the energy associated with motion, position, or shape of an object. So the position relative to like gravity, its shape, a rubber band being stretched or relaxed, and its motion. Is it moving? So mechanical energy can be both potential and or kinetic. Some objects will have both, some objects will only have one or the other. So to calculate this mechanical energy, you would simply take the total potential energy of the object and add it to the total kinetic energy of the object, and that would tell you the mechanical energy of that object. In general, we're mostly going to be using the motion or position of mechanical energy related to gravity or movement. But the shape one is important to know as well. So a second type is nuclear energy. This is the energy that's formed from the splitting or bonding of atomic nuclei. It is always potential energy. There are 2 types, nuclear fission and nuclear fusion. Yes, the words are very, very similar. I'll tell you a little trick to help you remember it in a second. So fission is one that you're probably more common with. It's pretty common here on Earth. It's what we have in our nuclear power plants. And yes, when you think of a nuclear bomb, you are thinking of fission. What happens is you take a large atom, let's say uranium, and you shoot a neutron at it. This causes, because it's very unstable, the atom to, bam, break apart into 2 smaller atoms. This breaking apart into 2 smaller atoms releases a ton of energy, and that's what we harness as our energy. It's also what causes the explosion. So fission, how I remember fission, is you take one thing and you break it apart into 2 things, and that's why there's 2 S's, because you get 2 things at the end. Now fusion, you're fusing things together. This is most common in stars. In fact, nuclear fusion is how all of our stars glow. And it takes 2 smaller atoms, so in this case hydrogen isotopes, and it smashes them together very strongly to form a helium atom. And this also releases a ton of energy. And here on Earth, we would love to be able to use nuclear fusion as opposed to nuclear fission, because this releases far more energy than fission. But, one, it takes a lot of energy to cause these hydrogen atoms to fuse and become one helium atom. And so until 2014, it took more energy to cause fusion to happen than what the fusion produced, which is inefficient. But in 2014, we finally were able, for the first time ever, have a nuclear fusion reaction produce more energy than we had to put in to get it going. So that's very exciting. So in your lifetime, you may have such a thing as nuclear fusion, which could completely change the energy game of the entire world. So that's very exciting. Now we've also got thermal energy, also sometimes called heat. This is the total potential and kinetic energy of the molecules in an object. And it is both potential or kinetic. Heat generally goes from high temps to low temps. And the more potential energy you have, so the more particles in an object, and the more kinetic energy, the faster those particles are moving around, that equals your total thermal energy. We've also got electrical energy. Now, this is the energy of electricity. It can be potential energy, or more common, it's kinetic energy. It's very, very difficult to store electrical energy. In general, you have to use it right when it's produced. So most of electrical energy is kinetic energy, and this is one of the huge challenges in energy production, because we can produce a bunch of electricity, but if it's not being used right away, it's very hard to store it for it to be ready to use when we do need it. So this is a huge challenge in terms of our energy sources and providing the energy we need to run our daily lives. We've got electromagnetic energy. It's also sometimes called radiant energy, and it travels through space in a vacuum. It does not need matter to travel. And this includes visible light. It is kinetic energy. It's moving. So remember back to 6th grade, your radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-ray, and gamma rays. All of these are electromagnetic radiation, and they all involve movement. And lastly, we've got chemical energy. This is the energy of chemical bonds, and it is always potential energy. So think of batteries or food or photosynthesis making glucose. All of these are storing energy in those chemical bonds. Back to ionic and covalent bonds. Ionic bonds are stronger bonds. They have more energy than covalent bonds. And so covalent bonds are easier to break apart than those ionic bonds. That's it. Be sure your notes hit all the key concepts and vocabulary, and feel free to try this challenge question.